Alright, looks like we're live. Hello everyone and welcome to another Zoosing session. How about that? Alright, so let's make a little bit of an announcement and officially start the stream. Red circle this time, live on Twitch. And what are we doing today and on Twitch? Today we continue developing Breakout clone in Jai, but today specifically I wanted to work on a little bit of a particle effect. Right, so we're gonna talk about that in a minute. So I'm gonna give the link to the stream, twitch.tv/Tsoding, and I'm gonna ping everyone who's interested in being pinged. My computer has been extremely slow today for whatever reason. I don't really know why. Let me see. Let me see. So yeah, there we go. Just a second. Alright, so everything's fine with my computer. So you can find the source code for the game I'm developing here if you're interested, right? So you can find it here. Hello everyone, welcome. So it's just a simple game to try out Jai, right? So I'm using it as just basically a playground to learn about the language. So let's take a look at how the game looks like right now. So I probably want to actually do tmux, and I'm gonna do Jai break, right? So opt Jai bin Jai Linux, and we're gonna try to build I just remember that I made the first executable so I can actually build the whole game by just running first, and it doesn't work. Probably because it just points at the wrong interpreter. Right, so let's take a look at the stuff, Jai Linux, and this is going to be first Jai, right? There we go. And this is how the game looks like, right? So this is how it looks like. It's a pretty simple game. It's just straight up like Breakout clone or something, right? So on the previous stream, to learn about metaprogramming, we implemented our own hot config reloading, even though like Jai standard library, if you can call it standard library, has its own thing. I still decided to implement the thing myself just to learn more about metaprogramming in this language. So, and I think it was actually a pretty good exercise. So let's take a look at this thing. So we have a couple of parameters, like not a couple of, but quite a few parameters in here, right? So, and this is basically a configuration file that is parsed by a special module, params.jai, and it can be used either at compile time to sort of bake the values from the configuration file into the executable, or it can be used at runtime to hot reload the thing, right? So just depending on the mode that you build, it will basically bake the values, or it will just hot reload them. So if there is the debug sign in the corner, that means we're in debug mode, and that means we're hot reloading the values, which means in turn that I can modify things. For example, I can take the background color and make it a little bit more greenish and reload. As you can see, I didn't have to restart the game. Or I can make it a little bit more greenish. There we go. So I can just like reload the thing. So of course, Jai has its own thing for that, but I implemented my own one just to learn things, right? So, which is actually pretty cool. Right, so, and to build the release build, so to speak, that bakes the thing into the executable. Oh, thank you so much, John, for the rate, 464 raiders. I'm not really doing anything special, so I'm actually gonna disable the followers mode just in case, like people who don't want to follow me just want to say something. Right, I'm not doing anything special, I'm just learning the language. I only recently got into beta, right? I was invited by one of the keys. Thank you so much for inviting me. Yeah, so I just like implemented a simple breakout clone. And yeah, it's actually, I really like the language. So I've been having a blast like just using it. I think it's pretty cool. So I like it so far. So, all right. Let's see. And the source code, you can find the source code in here if anyone is interested. So it has its own hot reloading configuration thingy that doesn't use the thing that comes with Jai, and it is not because whatever comes with Jai is bad. It's just like I wanted to learn more about metaprogramming, so I implemented my own thing. And it kind of sucks because I don't know much about metaprogramming in Jai, so I just like hacked something together just to get the idea of how it works, and maybe in the future I'm gonna improve it. Right, so all right, so okay, what I wanted to do, I wanted to implement some sort of like particle effects, I suppose. And the particle effects I want to have is basically just something when the ball hits any of the surfaces. Right, so essentially when the ball hits any of the surfaces, we can, you know, emit a bunch of particles from that specific place, and maybe it will look good. I don't know, I'm not a game developer, so maybe it will look good. I just want to try that and see how it goes. Okay. So how can we detect a collision? So if I take a look, so we have a horizontal collision. Okay, so here are all of the possible collisions that we can have. We can have a bar collision. Bar collision is actually very interesting, right? It's a collision that prevents the bar to penetrate the ball, right? So, and do we want to play anything on that? Probably not, so probably only care about horizontal and vertical collision. So in horizontal and vertical collision, so here we essentially hit either one of the sides, right? One of the horizontal sides, or the bar, and here we possibly hit the target. So in two of these places we'll have to play the particle effect, I suppose. When are you going to do Wordle clone? The thing is, I don't really know how to play Wordle, so I'm really sorry. I'm not American, that's the thing. I don't understand that meme. And I was too lazy to actually learn about it, so I'm really sorry. So link in Discord, it's too late to fix, I'm sorry. You found my stream anyway, so that means the link is fine. Where are you from? I'm from Siberia. It's like Asian part, or Eurasian. It's really, really far away. Geographically and culturally. Is Java pretty stable as a language at this point? I couldn't break it, so, but I don't know. I've been using it for like a week or so, maybe less, or maybe more. I don't even know for how long I've been using it, but anyway. All right. So where we have the state of the game. So here's the very simple state of the game. So maybe we should introduce some sort of a particle, right? So let's actually introduce a structure which is going to be a particle. Right? A particle. Particle. I like that. A particle. So this is a structure, and in here, what we're gonna have. So what a particle usually has, right? It usually has a position, right? So it's probably going to be something like x and y. Should probably use vectors, but for some reason already here for the targets, right? At the top, I already use like separate variables, so maybe I'm going to just follow this thing. Okay. So particle usually also has a velocity, right? So it's going to be dx float 32, right, and dy float 32. So what else does it have? It probably has a size, because we probably want to play particles with different size. So this is going to be a size, and it's probably going to be something maybe from like, so 1 is going to be the normal size, right? And less than 1 is going to be smaller, and bigger than 1 is going to be bigger, right? So something like that. So it's more of like a size multiplier. And probably some sort of a lifetime, right? For how long is it like he's been living? Maybe it's going to be some sort of a value in seconds that gets decreased on each frame by delta time, and as soon as it hits 0, we're going to consider this particle dead. Something like that. So that's going to be basically an idea. All right. So, and since this is the state of the game, we're gonna have an array of particles, right? So right now I'm not developing any sort of like a particle entity that manage everything. I just throw everything in a global scope because it's easier for me to just like manage those things. And at some point when the complexity grows too much, I'm gonna be grouping them into the structures and structuring everything properly. Right now I don't really care, right? It's just like put everything in a global state. How do you feel about Jai? Jai is a programming language for developing software. Developing software is about engineering, not about feelings. Okay? Got it. How do you get access to Jai? Well, I had to bribe a lot of people. I'm joking, so I wasn't right. How do engineering about Jai? That's a good question. So, the question is, the array of particles, what is it going to be? Is it going to be a resizable array? Or an array with a fixed size? Right. So as we emit the particles, right, we're gonna probably simply append them, right? We're gonna append them to the array. And when they die, we want to be able to reuse some of the particles, right? We want to reuse some of them. So maybe if we had sort of like a limited capacity of the particles, it would be actually super easy to allocate a new particle by just iterating it, like iterating this array. Like thousand of particles is just like not too much, so maybe iterating it is not that difficult. Is being snarky required? Of course it is a requirement. All right. Yeah, I think that's the easiest thing to do right now. Yeah, that's actually pretty cool. Because every time if I want to allocate a particle, I just like find the one with the lifetime less than 0, and I just allocate that particle. Right. So that's going to be the easiest thing to do. Okay, that is fine. So right now I suppose they're going to be all filled with 0. It's a really dumb approach, okay, right? But we're making like a very simple game, so it should be fine, I think. I think it should be fine, hopefully. So here we reset the state of the game, and do I want to do anything with the particles? Probably not. I probably don't care. Anyways, so let's do something, right? Let's do something. So rendering, we need to find the function that renders things. So here we set the shader for the core, then we render the projectile, then the bar, then the targets, and then we probably want to render the particles. So let's do particles, right? So this is the particles, and we're going to render each individual particle in here. So how are we going to be doing all of that? So we probably need to construct some sort of a rectangle, right? So because we have a function fill rectangle, right? So let's call this particle rect, and this one, let's call it particle color, right? And I'm gonna add the particle color to the params. Particle color, right? So what's gonna be the particle color? I don't really know. We can, well, by the way, what if we have particles of different colors? I think that's a cool idea, right? So depending on what you hit, it's gonna play different, it's gonna emit, I think it's called emit, right? So it's gonna emit particles of different colors. So I think because of that, we wanna do something like color, right, vector 4, right? So you have a position, you have a velocity, size, lifetime, and the color, right? I think that's actually pretty cool. So random. So and because of that, we take the color from here. Right, so now I need to construct the particle rectangle, right? particle rect. So in a rectangle, if I remember correctly, it's just x, y. All right. Particle rect. So the position is going to be probably the position of this thing, but I want the position of the particle to represent the center of the rectangle that we're, drawing. So that means I need to figure out the size, right? So initially I have some sort of a size, right? So it's its size, but its size is just a multiplier, right? So we need to have something like particle size, right? It's a base size. Maybe we should call it like a base size, right? It's a base size, and I'm gonna put that into the configuration right away, and it's gonna be a float, and the size is gonna be, let's say, maybe 10, right? So it's gonna be roughly 10, and this is going to be the actual size that we use. So if the position of the particle is gonna be the center, that means we need to subtract half of the size, right? So we're subtracting half of the size from x, and then half of the size from y, and then particle w becomes size, and particle h becomes size, and there you go, we can render the particle. Interesting enough, can I do something very cool and put a using in here and just get rid of these things? I think I should be able to do that. I think that's pretty cool. Right, so basically you import all of the names within the structure into the current scope, and when you do x equals to that, you assign to x in here, which is actually pretty cool. I really like that. It makes it a little bit more readable, I think. Maybe. It actually depends. Readability is a very subjective thing, right? So... all right. So people are talking about garbage collection. I wonder if you can implement garbage collection in Jai. I think you should be able to with the with some sort of metaprogram or something like that. Maybe. I'm just thinking. Yeah, I guess. General show up at your house. By the way, speaking of, blasphemy, I was thinking how to implement borrow checker for Jai. Because again, you can intercept the compiler events, right? So that means you can actually have enough information to implement an actual borrow checker as a library. So I was actually thinking about that. Oh yeah, that's why I live in Siberia, by the way, so nobody will get me. Alrighty, so let's try to build this entire thing. opt jai bin jai first jai. There we go. So what do we have in here? So if I go to semicolon, still semicolons. Unbelievable. Okay, cool. So, and if I try to run the game, right, it shouldn't break, and it doesn't really slow down either, right? So just iterating thousands of things is not that much of a computation, so that should be fine, I think. Though we don't really do anything. Oh, all of them are 0. Wait a second. Huh. So that means they should be somewhere... Oh, their colors are... Okay, I see what's going on. Their colors are invisible. That's why they're probably rendered somewhere here, right? And they're invisible. So right now we are rendering 1024 invisible particles right in here. Oh, maybe in here. I think I switched coordinates to be studying it here. Right, so that's what we do right now. We can try to put some sort of a color in here. For instance, let's put a reddish color of some sort. Right, so it's gonna be like that. And let's see, do we see anything? No, we don't, because I didn't rebuild this entire thing, of course. And so then I'm gonna just run this entire thing, try to break. Yeah. You need to provide... Ah, sorry. I really like that it apologizes. So, I mean, there's no really need to be sorry about that, right? It's my mistake, but the compiler is still sorry for not being able to read my mind. I appreciate that. Anyway, so there we go. So we have a couple of problems in here. And declare target. So something went horribly wrong. How is that? Am I being an idiot? Like, I didn't really do anything and it stopped compiling. Oh, okay. I'm sorry. I should use first. Yeah. Just realized that. Okay, cool. So I have to bring back this entire thing. Okay. Do we still render anything? It's kind of strange that I still don't see anything. So I would expect to see at least something, but it really doesn't render anything. So the size, base particle size, we can try to increase the base particle size to maybe 100, right? And maybe then we'll see something. No, we didn't see anything. Okay, that's fine, I suppose. Anyway, so maybe I just need to continue developing this entire thing, right? So because I would expect to just like draw some stuff in there, right? So if I explicitly put some sort of a color in here, right, some specific color, would it actually do anything? No, it doesn't do anything. That is really strange. But if I put something like that in here and then do something like well, sure. Okay, I see. Okay. The size is 0. Right, so it still renders thousands of the particles, but their size is 0. So to make them visible, finally, right, so that's what I'm trying to achieve. I need to also assign 1 to here. And now they're visible, so this is 1024 particles are rendered in the left top corner, right? So, there you go. Now, we can change the size to 10, and as you can see, so here are all of the... So, all of the 1024 particles are tightly packed in a corner. That's the power of this language. That's what you can do in this language. You can render thousands of particles in a corner. Can your Zig do that? I don't think so, actually. So, sorry. It's a very efficient compressing, I know. So one of the things I want to do in here, right? So I want to ignore the particles that are dead, right? There is no point in rendering the particle that is dead. So if its lifetime is less or equal than 0, right? If it's less than or equal to 0, then maybe you want to just continue and skip the entire particle, right? Or maybe you want to go a little bit more modern and just like wrap everything like that, because kids these days say that this is more readable. Again, ignoring the fact that readability is a very subjective thing, but anyway. Okay, so let's go ahead and do that. So thousands of particles, well, I mean, if you want to do that, you want to actually do something like this. There we go. Cool. So not a single particle is rendered right now because we're ignoring everything that has lifetime 0 or less. So, which is understandable. Cool. So now maybe we want to emit a particle, right? So let's create a function. Particle. Single. Right, so we're gonna emit a single particle. So we wanna emit it somewhere at a particular position, I suppose, right? So the position is gonna be x float 32, and y float 32. So right now we're gonna hard code all of the parameters or something. Also, we want to have a particular color, right? So it's gonna be vector 4. So this thing is not going to return anything. It's just gonna find any free particle and just allocate something there. The way it's gonna work is that we're going to just iterate all of the particles, right? We're iterating all of the particles, and as soon as we find anything that has less or equal than 0 lifetime, we're gonna allocate a new particle right there, and we're gonna break out of the loop. So if you don't have enough particles, right, so it's not gonna allocate anything, so it's gonna be capped at 1024. That way we don't have to think too much about memory management. If you allocate too many particles, they're just not gonna be rendered. Right, so that's basically the idea. That's the entire memory management when it comes to this particle system. It's a very dumb particle system, but again, I'm not a game developer, okay? So I don't know how to develop efficient particle systems. I know how to develop the ones that are super simple and dumb, but anyway. So, how are you liking Jai so far? It's okay. Would you recommend me waiting for it? I have no idea who you are. Why would I... How can I even answer that question? Only you can answer that question. Nobody knows you better than you. So I cannot answer that question. Okay, so we're gonna have in here. We need to start at a particular position, right? So this is gonna be that, and this is gonna be that. So the next thing is that we need to create some sort of a velocity, right? First of all, we probably need to pick a random direction, right? So we need to pick a random direction in which we're gonna be moving. So... The question is, so we're gonna have a random angle, right? So this is a random angle. And essentially I need to be able to have a random value from 0 to 1, right? If I could have random value from 0 to 1, I could then multiply this thing by 2 pi and get a random angle, which I then could use for, so x is cosine, right, like this, and then for dy, for the sine, right, and then here somewhere I could say something like particle base velocity, right, so this is a particle base velocity, and we could probably also multiply that thing by a random value. By a random value. So I don't remember, how do you do random stuff in Jai? So I'll probably need to look up the modules, right? So that's how I usually do. So I'm gonna grab, maybe it's somewhere in basics, right? So do we have random? I don't remember. I think I used it once, right? So I think I used it once. So let me see. Grep or n rand. Right. Do we have something like rand? Or drand? I don't remember. Random. Maybe it makes sense to actually look that in basics, right? Because this is where you would put that. Okay, this is a bit painful. I don't remember where it was. Okay, so there is a whole module called random. Okay, so that's fine. So random get, and you can just get a random. Okay, that's perfect. That is perfect. So random seed. So you can do within the range for floats. Okay, this is basically get 0. It's even called get 0 to 1. It's even called almost like I called. What the fuck? Alright, so I mean, it's fine. All right. Cool. So we can do something like that. So this is the angle, and also maybe I'm gonna have a different velocity, but I'm not really sure how. Yeah, we'll see. We'll see. So yeah, we have a velocity now. The size is gonna be something like IT size. And I suppose for now, random within the range, and the range is going to be 0.5 to 1.5. Right, so it could be half of its original size, or more than, you know, one and a half of its original size, something like this, I think. All right, so, and the color, its original color is going to be the one that we assigned, so this is the color. And lifetime is going to be particle base, not really base, but just lifetime, right? So something like this. Particle base velocity. Okay. Okay, so random get, so we need to include the random. Okay, so particle based velocity, I'm gonna go here, and something went wrong and declared identifier. Oh, because I never actually did that. So the base velocity is gonna be, let's say, around like 100, right? So something like 100. So what else do we have? Lifetime and particle. Let's call it lifetime. So it's gonna be float. And lifetime, how many seconds? Let's say it's gonna live for half of a second. I don't know. Well, cool. That's pretty cool. And now we need some sort of emitting process. Right, so, but the question is, like, if you want to emit the particles, you emit them with a particular period, right? So you emit them with a particular period. Why the parentheses in the constants? Because the constants could be hot reloaded. All right. So here is the thing. The constants are coming from params.conf, right? So we're taking this thing and we are generating this kind of stuff, right? So essentially each function call gets that value from the hash table. But if I change this thing to false, right, and recompile it yet again, let me try to do that one more time, right? It sort of bakes all of these values in here. So these parameters can be either runtime or compile time depending on the build, right? So in the sort of release build, they get baked. In the debug build, they are hot reloaded constantly. That's why the call. So it could have been done a little bit more clear, right? Clean, a little bit more clean. For instance, maybe I could have a meta program that would find all of the constants like this, and for debug build it would replace them to function calls, but for the release build it will leave them constant, so the compiler has like easier time to fold in everything, because I'm not sure if the compiler right now would inline such functions and then fold the constants, because that was my hope by implementing all of that. So, but that's basically the general idea. I did all of that just to learn about metaprogramming in Java, like generally how to do that. So it's a really hacky and dirty solution, but this is because I'm only learning things, and yeah. That makes sense. So essentially these are parameters, these are basically parameters that probably has to be compile time, but during the development it's kind of nice to have them runtime, right? Because you want to hot reload them. Which probably is not really that important. I don't think it's that important of an issue. It's more of an exercise, right? So all of that is more of an exercise. If I was doing like an actual commercial thing, I would probably not care about this kind of stuff right? Until it's actually needed, right? So all of that is not really actually needed, it's just like whatever. Just playing with things, just experimenting with things. Do they get reloaded while the game is running? Of course. So let me go and build. It's not something new. Jai already has a thing that allows you to hot reload the configuration. It's just I didn't use that because I wanted to learn about metaprogramming. Alright, so... Okay. Let me actually also run it right away. So if I go to params and for instance I find the background color, I can change it and then hot reload it. So the game is still running, as you can see. It is still running, so at any point I can just do something like boom and keeps running. So something like this. So it's not something special or new. People have been doing that even before Jai existed, right? So they just had like a separate meta program. Okay. All right. So let's actually focus on the thing that we actually need to do. Okay. So we need some sort of a period, right? We need some sort of a period. Particles emitter period, right? So this is going to be float, and in here, particle emitter period, right? So, and how quickly? Let's actually say it's going to be also half of that. Align with the regular expressions. There we go. Emitter period. So let's find the update. So here, if everything is not paused or started, we do this thing. Okay. Okay. Emitter period minus dt. If emitter period is less or equal than 0, that means the time has come. Particle emit. Alright, so we emitting a particle. Where are we emitting a particle? We can actually try to emit a particle at the projectile position. Okay, so we have a projectile position and basically we're gonna have a trail of particles for the projectile. So in the color, I don't even know what kind of color we're gonna put in there. Let's actually put something reddish. Right, something like this. So this is going to be a reddish color. And after that, I'm going to do emitter period, and it's going to be equal to particle emitter period. There we go. All right, so that should be it, hopefully. Let's try to compile the entire thing. And yeah, there we go. So this is the particle emitter. This is a particle system. So what's the problem with such particle system? Well, the particles are not updated. They are rendered, but they're not updated. All right, so that's kind of a problem. All right, so let's actually iterate through the particles, right? So here are the particles. And what we're gonna do with them? First of all, we need to update their position, right? So we have to do something like plus dx multiplied by dt. And in here I also want to replace x with y. There we go. So we are updating the position, so which is already kind of nice. All right. So now, as you can see, the position is updated. So they're flying somewhere. They're flying somewhere, which is pretty cool. So, but the thing is, they don't die. They never die. They're gonna, at some point, they're gonna waste the entire allocated like memory for them, and that is it. There will be no more particles. So what we need to do in here, we also need to update its lifetime. So we need to take the lifetime and subtract the dt, right? So that means that at some point they're gonna actually die. As you can see, they die, but when they die, they sort of disappear, which kind of sucks, don't you think? I think it kind of sucks that they just and snap out of existence. Like, it fucking sucks. So what we want to do is probably change its color depending on the lifetime. So maybe depending on the lifetime is going to have a different transparency, right? So let's do something like that. So okay, so this is the Oh, this one is really interesting. So I'm using just like a random color, but I'm supposed to use the particle color, the one that comes in here. But I wonder if there is like an easy way to update the alpha of the color, if you know what I mean. Maybe there is no, right? So, but the idea is the following. So I'm gonna assign the color, and then like that, and then take the alpha, right? So, and since the color is vector 4, it's gonna be W. So what I need to do in here, I need to take the current lifetime, right, and divide it by the maximum lifetime of the particle. So this is going to be something like this, particle lifetime. So I'm going to just divide it like that, and there we go. This is the color that I want to have in here. So maybe there is a way to do that in line, but I just did it in 2 lines. It doesn't really matter that much. Okay, so let's take a look at what's going to happen. And it didn't work. I really like that. I really like the fact that it didn't work. I wonder why. Ooh, X, Y, Z, W. I would expect that this would work. So that's kind of strange. So let me try to print the color and just see what's going on. Okay, so, and it goes down at some point, yeah. It does in fact go down. So, but it just doesn't take that into account for some reason. Is that something that I have to do for alpha? You have to set the shader. Oh, okay. Oh, okay, you probably don't know. Okay, so I should not listen to the chat because the chat usually debates me. Alright, so let me take a look. Let me see. Blend. So I probably want to also do something like this. So there is a gel blend enable, backend use shader. So there we go. So this is, I suppose this is what we need to do in here. So enable blend. Now let's go to here. I probably have to do it like that. There we go. Okay. And it didn't work. Very cool. Because it's false. Print. And okay, so as you can see now they sort of disappear, right? They sort of disappear. But you can notice a very interesting thing. The period is too big. The period is too big. They're really sparse. So let's actually go. Maybe I don't even have to restart. I don't know why I keep restarting because I have a hot reloading, right? So I can just do something like this, right? And then I can go to the parameters and, for example, change the period like in half, right? And then I'm gonna, just a second, hot reload it. And as you can see, it actually emits them a little bit faster, right? It emits them a little bit faster. We can make them emit even faster, like more than half, right? So now it is like that. Maybe they should live a little bit longer. Right, so maybe they should leave a little bit longer, but apart from that, it's kind of fine. So what about like just one? Yeah, that actually looks fine. What about half of one, right? So yeah, it actually looks pretty nice. So that's the particles. And now maybe I'm gonna make the lifetime a little bit longer, right? So because half of a second is probably not that much. So let's actually make them live a bit longer. Yeah, that's pretty cool. So the base size probably too big. What about 5? Right, so they are now even smaller. So if we increase the period like this. Oh, that looks fine. I really like how it looks like. Look at that. It's pretty cool. All right. So we can make them live even longer, like 2 seconds, right? How about 2 seconds? And now they're like this. Yeah, boy. So what if the base size is like 20? Right, so yeah, there we go. Now we're talking. So this is a bait size. It's not emitting from the center though. Who cares? This is a debug code. Who cares if it's emitted from the center? We're debugging particle system. What's important is that they're emitted at all from somewhere. They're emitted from somewhere. Okay. It's pretty cool. I could watch it forever. It's so nice. Is this hardware accelerated? Yes. It is accelerated by 10 years old hardware on my laptop. Can you make it fade from red to orange? I guess I can, but that's kind of interesting thing. All right, so let me see. Don't know why, but we can try to do that. So the final color could be, right, if this is the orange. So I remember that there was a lerp, so you could lerp from this color to another color, right? And the lerping thingy could be something like this. I suppose what you want to lerp it to, right? What you want to lerp it to, you want to lerp it to more like a yellowish, right? So something like this. And then once you get that, I can put it, well, I mean, I can just put it into the color, right? So, and maybe that will make something, all right? Well, that went kind of wrong. So if I'm lerping, I actually kind of have to invert it. But if I'm inverting it, I could have just done it like that. Right. So I can just invert it like so. What the fuck? I'm an idiot then. Is that what I have to do? Yeah. Is that what you want? Right, so well, it's not really into the orange, but it's fading into the yellow, which kind of, yeah. Something like this. So I suppose the orange is gonna be something like this. Yeah, there we go. So, and I probably have to blend the colors a little bit more like smarter, right? So I have to use the, for instance, when I initialize, I have to do the gamma correction, right? So I need to take sRGB to linear and do the linear transformations in a linear space, right? And then convert back to sRGB, right? So that way is going to be like more linear, if you know what I mean. So this is basically what I do when I generate the rainbow color for the targets, right? So I'm also linearly interpolating these colors, but I do that in the linear space, like converting things around, and that way it's actually more like uniform. I could probably demonstrate how it looks like without it. Oh yeah, I think I can demonstrate to you how the rainbow looks without the gamma correction, right? So because I made a commit at some point on a GitHub, so something about gamma, yeah, gamma correction. There we go. So, and here is the screenshot. So on the left, you can see without gamma correction. I'm not sure if you can see that, but on the left, you can see it on the gamma correction, and on the right, gamma corrected. Right, so without gamma correction, gamma correction. So, and if we take a look at the difference, right? Display reach diff. There was a way. Okay, so here is a swap. Okay, so look at this orange color. Look at this orange color. So without gamma correction, it's a little bit darker, right? So essentially, it basically interpolates very quickly. It fades into red too quickly, quicker than it's needed, so it doesn't really look like uniform. So that's basically the problem in here. So if I want to fade the particles a little bit like more nicer, I probably have to do a similar thing. Right. So you can clearly see this thing. If you're interested, I'm gonna give you the link to this specific commit. Did I get the private copy? I got into closed beta, yes. Right, I can also put that in the description just in case somebody's watching us on YouTube, right? So because I'm gonna be uploading all of that on YouTube too. Where's the description? Right. So gamma correction diff. Right. First rule of Java Beta is you don't talk about Java Beta. Why wouldn't you talk about Java Beta? It makes people jealous. Why would you miss such an opportunity to make people jealous? I don't understand. No, it doesn't make any sense to me. If you're in Java Beta, you better talk about being in Java Beta. I'm joking, of course. All right. So, okay, we have particles, right? So that's cool. The thing is, what if I want to have several particle emitters at different points? You know what I mean? So maybe I'll have to create. I didn't want to do that, but I have a feeling that I need to create a particle emitter entity, right? A structure. Though, if we're gonna have several particle emitters, they can use the same particle pool anyway, right? So they could probably use the same particle pool. So, and what's interesting is that I want to have several particle emitters that live for some period of time. You know what I mean? Because here's the thing. So you probably hit... I'll have to think. Right, you hit different surfaces, right? So, and when you hit a surface, you should emit a bunch of particles for some short period of time, right? For some short period of time, you should emit them. And since you can have several collisions, several of the particle emitters should live simultaneously, so they should be sort of concurrent particle emitters. So what I'm thinking is that maybe we can have also a pool of particle emitters. Right, so that kind of acts in a similar way, right? When you hit something, you spawn a particle emitter that lives for a short period of time that keeps spawning the particles. Right. That's actually an interesting idea. Maybe this is what we should do. Should the place you have hit in the course of the bar you hit? Well, I said that like several minutes ago, and the answer is yes, and this is why I introduced the core field into the particle. So I think this is what I'm gonna do. So the thing why I like that is because the particle emitters themselves become kind of like particles, right? In some sense. Anyway, so nobody cares. Particle emitter, right? So we're gonna have a single particle emitter, and the particle emitter probably should have the base place, right? So the base position. So where is it located? So, and also the base color, right? So all of these parameters. And it should probably have a lifetime, right? So something like this. Maybe let's actually call it emitter. Maybe particle emitter. I don't know. It's kind of difficult to tell. And emitter period is basically the lifetime of a single particle emitter. I watched your first few Java-vods. It was interesting to see someone approaching the language with relatively fresh eyes. Well, yeah, even then I knew a little bit of Jai because I was watching streams, right? So anyone who's watching John's streams, they know a little bit about how to use the language already. So, but I never like tried it myself. Oh, yeah, I already said that. Okay. Okay. Particle emitters. Right, so we're gonna have several of them. And how many particle emitters do we want to have? We can have, I would say, something like maybe 128. We don't really need too many of them, right? We definitely need more particles than particle emitters. Particle emitter, single one. Right, and there we go. So particle emit. And I suppose, right, I suppose in here we need to accept a particle emitter instead of a single particle. Yeah, I think that's what we need to do. Since you're in Russia at the moment, assume you don't have access to Twitch Arena, right? Yes, I don't have it. So what I'm thinking is that I want to have a function that accepts particle emitter, right? And updates the particle emitter. So we need to have something like particle emitter update, right? So this is a particle emitter update. And then we can have emitter, which is a pointer to particle emitter. Emitter. And we also need to accept the delta time, right? So this is the delta time. Okay, cool. And I suppose I need to take this entire code, right? So, yeah, I think this is straight up particle emitter update. Emitter update, right? It's just like instead of emitter period, we have a lifetime. No, not really. Period is its own thing. Yes. Period is its own thing. Lifetime is its own thing as well. So if lifetime is less or equal than 0, that means we return and we don't do anything. We literally ignore this thing. Then we take the period, right, and we perform these things. But instead of this thing, I just use x, y, and the color. Right, so this is the color. And then I also subtract the lifetime. Right, there we go. Okay. So I subtract the lifetime, the period, and if period is less, that means we emit a new particle. Right. So particle emitter update. Okay, cool. So where is the... excuse me? Am I an idiot? Okay. Okay, I couldn't find update for some reason. Alright, particle emitters. Right, and then I do particle emitter update it with dt. You know what? I'm gonna actually do it like that. There we go. You know what? The language has like function overloading. Maybe I could overload update. It's actually too difficult to then keep track of the things, so I'm not gonna do that. Alright, so expected. Yeah, of course, I can do that. So what else do we have in here? The hell? What the hell has happened here? I guess I accidentally just corrupted something with Emacs. Yeah, okay. This probably should not be here, that's for sure. I don't know what the hell is that, but something weird has happened with Emacs and it just like went crazy. Okay, so as you can see, we don't have an emitter, right? We don't have an emitter, and maybe this is something that we now need to handle, right? We need to emit an emitter. You know what I mean? We need a thing that iterates through the emitters, finds the dead emitter, and creates a new one for a particular period of time. Emitception. Yes, it is emitception. So how are we going to call such function? So it's going to be particle emitter emit. Again, I'm not a game developer, so I have no idea what I'm doing. So I'm just like doing the thing that makes the most sense for me, right? I don't really have like a proper experience in like making games or anything like that. So I'm probably doing an absolutely dumb thing, but again, I'm learning, right? Anyway, so we're gonna actually provide the position, right? So where is it going to live? Also, we probably should provide the color, right? So it's gonna be vector 4, and probably we should provide the lifetime. Why not? Like for how long this emitter is gonna stay there, right? For how long is it staying there? So, and I'm gonna just iterate through the particle emitters. Right? And if the lifetime of this particular particle emitter is less than 0, that means we found the one and only, the particle emitter we need. Not the particle emitter we deserve, but the particle emitter we need. And there we go. Let's actually initialize it. So then I'm going to do something like X and Y, of course. So the color is going to be the color that the user provided, right? The lifetime is going to be the lifetime the user provided, and the period, I suppose, is 0, right? So, and after that we want to return. So we just like emitted a particle emitter. Emitted a particle emitter. All right. Cool. So when do we want to emit a particle emitter? Well, depending on what we hit. So let's actually take a look at the collision, right? So here we have different sort of collisions. So this is a collision for borders, left and right borders. So this is entirely horizontal collision. So everything that happens here is a horizontal collision. So I think what I need to do, I need to split the border collision and the bar collision, right? So because depending on what we hit, we're gonna actually play things with different colors. So Rafael Luba, I hope I pronounced your name correctly. Thank you so much for 7 gifted subs. Thank you. And everyone who got the sub, welcome to the Epic Zozin Club. Thank you so much. So, okay. So here, if we hit the borders, we probably should render the emitter with the color of the projectile, right? So that makes sense, kind of. So particle, emitter, emit, right? So the position is going to be the position of the right of the projectile. Proj Y. And by the way, now we probably care about the... Rafael works on the compiler. Nice. Wow, the actual compiler developer. That's so cool. What is point of gifting a sub? Well, it kind of makes sense to gift a sub because you get pretty cool emotes that I primarily draw myself, right? So majority of the emotes in this channel I drew myself. Also, you get an automatic access to the Discord if you're subscribed, because I still use subs as a ways of moderation. Even though I don't get any money, sort of money becomes some sort of a filter for people to prove that they're not spammers or anything like that. And it actually reduces the amount of moderation work I have to do. So yeah. And maybe eventually, I don't know when, I will get this money, because Twitch just accumulates them. It's just like it cannot pay them off to me, but it keeps the money. Yeah, there's a lot of reasons to do that anyway. So, and of course, the most important reason, you make the Jeff Bezos more rich, right? Why wouldn't you want to do that? Okay, so here. We need to take the projectile size, right? We need to take the projectile size and add half of it, right? So we're going to be adding half of it, right? So that way is going to be at the center. And the color that we're going to be using, right, since we're hitting the border, is the projectile color. Why is it here, though? I think I need to actually put related things in, like, closer together. A little bit closer. There we go. So this is a proj color. And lifetime, I'm not really sure about the lifetime, so it's more of a, like, emitter lifetime, right? So we're gonna have something like that. Maybe particle emitter. Particle emitter lifetime, right? Particle emitter lifetime. And for how long they're gonna live? I don't even know. Maybe they're gonna live. If the period is this, should it live for? It's actually very interesting, right? So if I set the period to this. If I set the period to this, and then I set the lifetime to this, that means it's gonna emit like 10 particles. So I can sort of like measure it out to some sense. Right. Oh, it's actually pretty interesting. Okay, well, we'll see. We can experiment with that. We can experiment with that anyway. Particle emitter lifetime. Alright, so, and in here, okay. So the only difference between these two calls is the color, so maybe I could actually express that a little bit better, but whatever. So here, when the ball hits the bar, we want to actually play it with the bar color, right? So this is going to be bar color. This is a bar color. And now, if we hit one of the targets, and all of that horizontally, by the way, one of the targets, we want to play the color of the target itself, right? Oh, this one is interesting. We have a special function that registers the target hit, so I can play the particles in there, right? And that actually saves me a lot of code duplication, right? Target hit, right? Because it happens on both horizontal and vertical hit of the target, right? And I can just take the target, target color. I think it just has a color. Oh, and of course, I always use the projectile. It would be kind of cool to actually play the particles at the point of hitting, but I'm too lazy to actually figure it out. Is there a game where everything is a particle emitter? Depends on the definition of particle emitter, I suppose. Which one will dominate in the C space? Jai, Zeek, or Hair? So here's the thing. I think language doesn't really matter in making language popular, right? So let me put it this way. The language by itself doesn't make itself popular, right? So it's not really the features that make the language popular, it's rather how many talented programmers are using this language. You know what I mean? The popularity of the language depends, it correlates very strongly to the amount of talented people who use it, right? So I hate that game. Which one? Why? Anyway, so speaking of which language is going to become more popular and is going to dominate the C space, the one that attracted more talented developers. Now here's the question. This is a very important question and you have to answer it honestly. Which language, Zeek or Jai, attracts more talented developers? I'm not going to answer that question. You have to answer that question for yourself. The language itself and the feature of the language don't really matter that much in becoming popular, specifically in becoming popular. They're important for like other things, but for becoming popular, they're not that important. So what's important is who attracting more talented developers, who can actually make things, who can deliver things, who can come up with interesting ideas. Rust, easy. Well, this is one of the reasons why Rust became popular. All right. Anyway, maybe I'm wrong. So I know nothing about making popular languages because I haven't created a popular language. So I don't know. What do I know? I just wish we stop evangelizing things. Yeah, same. So the evangelizing things kind of distracts from actual development. Anyway, so particle emitter. So this is the particle target color, and so the only thing I need to do now is to handle the vertical collision. And in the vertical collision, I already have a separation between the bar and the borders, so I can quite easily just copy paste whatever I have in here and whatever I have in here, and there we go. So now when we collide with things, we actually create emitters, but I have no idea if it's gonna suck. I'm pretty sure this entire thing is going to suck. So let's actually see how much is it going to suck. Okay, so it has enough time to play like a single particle. You know what I mean? So maybe it should actually live a little bit longer, right? Okay, and of course I think the particle size should be smaller, of course. So let me say the particle size is going to be around 5, right? Doesn't look that bad, if you know what I mean. Maybe the emitters could live a little bit longer. Let's actually make it twice of that. All right. You can't see much because we're hitting like a different space. Can you even see that? Can you even see what's going on there? I think it's fine. I kind of like how it's going so far. It's kind of also the speed with which you can emit the particles is limited by the FPS as well, right? So what we probably have to do, we probably have to handle DT more properly. So essentially, if DT is bigger than the emitter period, it's not gonna really work well. You know what I mean? So that's kind of the problem. So that's why we actually see less particles than we should have. So I think this is something that we have to handle properly. But so far, apart from that DT bug, I think it looks kind of nice. Is it even visible on the screen? I started judging languages by what is actually made in them. I think it's a good idea actually. Some years ago, Lisp was supposedly best at everything, and then it was Haskell. Is there anything that is made in those languages that is being used by anyone? Yeah, but Facebook's spam filter. The main argument of the Haskell developers. Every time you start to criticize Haskell for not being used anywhere, they whip out the ultimate argument. The spam filter at Facebook that literally nobody has seen. Some mythical spam filter at Facebook. It is developed behind the closed doors. Nobody ever sees that spam filter, but it's there, and it's written in Haskell, and it makes this language great. So, and it doesn't even work. Yeah. Yeah. Don't you dare say anything about Haskell. Spam filters at Facebook. Spam filters at Facebook. Anyway, Considering Facebook only has a spam for content, that doesn't give me high hopes. Yeah, exactly. Considering like how all of these companies operate, like Twitter, Google, and Facebook, their spam filters are not really spam filters. They're competitors' filters. So what they do, they don't really filter spam. They are eliminating the competition. That's what they are, effectively. Because they don't want anyone else's spam to compete with theirs. You know what I mean? Okay. Though I know almost nothing about Facebook because I never used it in my entire life. Like, seriously, I don't even know how the front page of Facebook looks like. Like, I've never used it. I had to create a Facebook account after 30 years of my life because everyone in Serbia use it. Oh, I see. Isn't Russia using something like VK over Facebook? Yes! I never used VK either. Yes. Everyone is talking about Facebook, VK, and stuff like. I never used any of those things. Like, I have no idea what they are. Oh yeah, I also use Google Plus. Okay, so what I want you to fix, I want you to actually fix the emitting thingy. So when I update, so here is the interesting thing. So this is a period, right? So if this thing is less than 0, right? If this thing is less than 0, what I need to do? I need to take an absolute value of that period. Look closer. I take the absolute period of that thing. So if dt is bigger than the particle emitter period, if it is bigger, so that means that value, the absolute value of the period, may also be bigger than the particle emitter period. So I take this thing and divide it by that, and that gives me the amount of particles that I have to emit, essentially. You know what I mean? So it's gonna be rough. Probably there will be some sort of like a off by 1 error somewhere there, because there's also a remainder that I'm gonna ignore, but it's just one particle, right? It's gonna be just one particle. It's off by 1, and it's like effect. It doesn't really affect too much, so I think I'm gonna be fine with any of the bugs, off by 1 bugs that I introduce in here. Like, I really don't care. And we can do something like this. I'm also gonna cast it to integer, right? And there we go. So, and the thing I want to do in here is essentially just iterate n times, right? So I'm iterating n times. Though, if this thing is less, that means I actually want to iterate it like that, right? So, and that's how many particles I want to do, right? So, because of that, this may generate shit ton of particles, I think. I think it may generate shit ton of particles, but we'll see. So we can kind of do a similar thing for particle emitter emit. Ah, no, not really. No, we don't have to do that, so I suppose we only need to do that here. Okay, so did it recompile? I should probably use something like this. Oh shit, now that's what I was talking about. This is precisely what I was talking about, right? So, we didn't see enough particles. Now it's just a fireworks. I really like that. It's actually really fun. It's literally fireworks, yeah. But it takes into account the GT properly, more or less. I really like that. There's something to it, don't you think? I think it's pretty cool. Anyway, so that only means that we need to adjust all of these things, right? So we need to adjust them. So maybe the emitter period has to be 10 times smaller, right? So yeah, it is better now, right? It is a tiny bit better, right? The period is not as crazy anymore, but maybe the emitter itself should live a bit longer, right? So what if we make it live twice as long, right? So, and since it lives twice as long, it just manages to emit more particles, right? Or something like that, yeah. So in the particles themselves, maybe they should live a little bit shorter, right? That's weird. Okay, that's fine. By the way, do we vary the velocity of this thing? I don't remember. I think we don't vary the velocity. Let's actually quickly fix that. J, break, J, something. So when I create this, we do not vary the velocity. Look at that. Okay, so I can do kind of a similar thing. I can just, yeah. So sort of a parameter t, and I just multiply by that parameter in here. Right, there we go. So I mean the length of the velocity. So variation for the length of the velocity. Okay, so that's a little bit better. So they're not really circular anymore, if you know what I mean. But now the emitter just lives for too long, I think. So I'm going to change the emitter lifetime back to what it was, like units of the second. Okay. That's fine. That is actually fine. All right. I really like that. So, of course, there's no death condition yet, because I haven't implemented it. But we're gonna implement it at some point. Yeah, nice one. So let me make the period maybe slightly faster, just slightly, a little bit. Is it gonna be too much? I think that's fine. Okay, so velocity. Where is the velocity? Velocity is 100. What if it's gonna be a little bit faster? So it looks a bit more impactful. Oh, I really like that. So if we, yeah, so it feels like they hit with a greater force, you know? Okay, so I can change the size of the particles, right? So it's a little bit bigger, so we can see them a bit better. But maybe it's too big. All right. So they actually spread too much. So because of that, I think I want to reduce their lifetime, right? So they actually die a bit faster, hopefully. What about like half? Yeah, so they die a bit faster now. Oh, and by the way, I just realized that I still have this weird fading to an orange color. That's why it looks so weird. Yeah, I need to fix that as well. So it was an experimental thing. Update, and when I render, so particle, render? No. So what I wanted to lerp, yeah, so I essentially wanted to just have IT color, then color W, and just this thing. So that's the only thing I wanted to have. All right. So let's recompile this entire thing, and yep. So now it's the same color. It's the color of the thing you hit, right? So it's literally the color of that thing you hit, more or less. Yeah. Cool. So I think this is roughly what I wanted. I don't know why I studied the whole game, but yeah. Okay, that's pretty cool. Bonus challenge, make particle bounce on the bricks. That will be also kind of interesting. So that will require, you know what? That will require actually factoring out the collision detection. So right now collision detection is sort of hard-coded. on the projectile, right? So that means you have to generalize it to work with any rectangle. So, and that's a little bit of work, which I can take, after a small break. So do something like a combo counter. Yeah, we're gonna do that. Where the emitters emit more particles as a combo counter. That's an interesting idea. Yeah. So like the intensity of the thing. That sounds interesting. But yeah, we kind of developed the particle system, right? It wasn't too hard. And we didn't even have any engine for that. You have to have an engine to develop a game. You just have a particle system without any engine. How about that? Not a single engine. Not a single company will tell me, oh, you have to pay us if you want to sell the game. No, I don't use any engine. I just like develop this thing myself without an engine. How about that? I bet you didn't expect that shit to happen. Haha. All right, so I think I need to make a break, right? So let's make some break. All right. So let's implement the last thing, right? So the last thing for today is going to be collision for the particles. I think that is going to be very much interesting. So right now, as I already said, we only handle collision for the projectile, but we need to factor it out to any rectangle, right? So that's what we need to do. So the entire collision is handled by two calls, horizontal collision and vertical collision, right? So in here we have the position of projectile, right? So this is the position of projectile, and we use the size of the projectile to find stuff like that. So basically what I think we need to make the projectile position a parameter that can be modified by this thing. So essentially, we need to pass the position of something, right? It could be either particle or it could be projectile, right? So this is the position, right? And as you can see, or maybe not. So this is just a position. Oh, the problem with this thing is that it also updates. It also updates the position. So updating the position and collision resolution is part of the collision detection. Because if there is a situation when collision is sort of inevitable, collision will result in something bad, the move is not made at all. You know what I mean? Right. So that's why the collision and movement are so tightly integrated together. So I'm not sure if it's going to be easy to do that, but I'll try. I'll try. So, did John correct the weird error message with not okay? Yeah, he did. So I haven't checked it yet because it was released on recently. But he said that he fixed it, and I have no reason to not believe him. All right. So maybe because of that, we're gonna use the same movement in here. Yeah, I think it makes sense. Right. So the movement of the particle is also going to be updated by the collision process. I think that makes sense. I think does in fact make sense. All right, so here, so this is x and y, and we also need to accept dx float 32 and dy float 32. So these are the things that we'll need to update, right? On top of that, we also need to know the size of the thing we're, checking the collision for. So we need to have something like a width. And the height. Of course, I should probably switch to vectors, but it's too much work right now, so it will require going through the entire code base and refactor, and I don't want to do it right now, so I'm gonna just like pass it as it is. Hello, Sojin. Do you think I can learn C as the first programming language? I have no idea. I don't know you. You are the one who knows you the best, so to answer that question, you need to try, right? So try to learn it as a first language. If you can do that, the answer is yes, you can learn C as a first language. If you couldn't do that, the answer will be no, and maybe you should try a different language, but I believe that you can. So you should just try and see. So these kind of questions, you can only answer yourself. Just right. Okay, so what we need to introduce in here is, I suppose, just to rename, just get rid of all of the proj underscore prefixes, right? So we don't have that anymore. So speed, yeah, speed doesn't make sense. I think we have to do it like that, right? So this is an absolutely new thing, and X will have to dereference both of these things. Nice code, by the way. So this is the, oh, this is actually pretty cool. Star is not the dereference in Jai, dereferencing is this. So in C, it would be actually kind of confusing, right? Because this is dereferencing and this is multiplication, right? But in Jai, dereferencing is this. So, and because of that, it's just like this. There we go. All right. Okay, and if we encounter this thing or we encounter this thing, so the project size is going to be actually width. Okay, I really like how parameterization actually makes this entire thing kind of simpler. I really like that. You know what I'm thinking? You know what I'm thinking? We need to signal in information about a collision upwards, if you know what I mean. Right. But we also need to somehow tell what exactly we hit. Right. So of course I can return a boolean, right? So and in here I can return true in case of detecting a collision, right? So I can do that. And here I can return false. But also I need to emit particles. But since I'm going to be using this collision for particles as well, I don't want the particles to emit more particles when they collide with something. Imagine, right, we're using this entire code, right, for the particles as well, right? And each particle hit generates more particles. So it's going to be like an exponential explosion of the particles, right? That's why this kind of thing has to be decoupled from the collision detection, right? So we have a collision detection, has to be decoupled from that. Alrighty. So, and the only reason, like the only information we need is essentially the color of the thing that we hit. It would be kind of nice to know what exactly we hit, right? But you can hit so many different things. You can hit a border, which is not an entity by itself. You can hit a bar, or you can hit a target, right? So we could just have an enumeration to tell what exactly we hit, right? We can try to do something like that. Or we can return the color of whatever we hit, which would be kind of weird. You have a collision detection function that returns a color of the thing it hit. And the color is the color that you should use for particle emission, which kind of makes it too specific. You know what I mean? It kind of makes it too specific. So what I'm thinking, maybe it should be enumeration, right? So 0 is going to be you hit the border, 1 is going to be you hit the bar, and bigger than 1 is going to be you hit the target. We can even do something like you can store the index of the target you hit, right? You can store the index of the target you hit, so then you can extract the color of that target if you want to, or something like that. So that requires like this kind of refactoring, unfortunately. All right, so this one is rather interesting. So if we're gonna have enumeration, right, so it's gonna be collision, right, we'll get a collision, no collision, right, so you can have no collision. Then you can have, well, 0 is probably gonna be null, right? Then you can have border, right, so this is one thing. Border, bar, target, right, so here we have 0. And essentially anything bigger than target is the target, right? Something like this. I don't quite remember how you define the enumeration of a particular type. I think this is how we can do that, right? So we're gonna just keep it like that. All right, and here we can just do collision, right? So we essentially return the collision. So when I hit the border, right? So I can just say border. Then when I hit the bar, I can just say bar. When I hit the target, I say target, target, plus an index. But I don't remember how to get an index of a for loop iteration. So let me actually see. I don't remember. So opt j module. So maybe how to for. So I don't really know. Number types array for. So this is the index that just gives me an index. I kind of remember in a hash table, if we take a look at the hash expansion, the first thing here is an index and then the value, right? So that means here I can use something like it index, and then I can just use it like that. You know what I mean? We can actually call it something like target and index. So the target is this. And the index is this. So this is basically how I approach that, right? So there is it index, right? Oh shit, okay, so that means it's I didn't even have to do that. Okay, thank you. Thank you so much. Right. It index. Oh, okay. Whatever. Alright. So this is basically how we're gonna signal the fact that, you know, we collided with something. Right. Border, bar, target, or no collision whatsoever. And then whoever calls this function, right, for any reason, should decide what they want to do with that information. You see what I mean? Right? So if we're using that to resolve the collision for the projectile, we want to emit particles. If we're going to use that for particles, we don't want to emit particles. In fact, for particles, we don't even care what we hit. We just hit something, right? So, and this becomes more and more abstract, right? So this entire thing becomes more and more abstract. Okay, so here we have a projectile rect, and I suppose, how do we construct a rect? Do we have just a rect? I see. So what I'm thinking is that I want to create a rect function, just construct a rect. Can I do xywh float 32 and then return the rect, and then do something like result rect result x equal x y w h, and then you just return this entire thing. So this is the result. Horse collision. Okay, so here what we have to do, we have to take correct x y wh. So this is a rectangle. We check that we intersect, and in that case we update the horizontal velocity, right? We update the horizontal velocity and also signal what happened. Target pool. Okay. Okay, why are you passing parameters as pointers? Well, we already answered in the chat. Thank you. Thank you so much for answering. All right, so here is another. Oh, this one is weird. I supposed to actually not use X and Y in here because I updated. I think I updated X, so that means I have to use an X in here. Yeah, and in here I also have to use an X and then the reference Y. Right. So I think that's how it's gonna work. Right. Then, oh, here's an interesting thing. Signaling this kind of stuff, right, that you hit target, actually enables us to decouple the target hit function as well. So this target hit could be called by whoever calls this function, right? So we can actually do something like that. And then we're gonna do it like this. There we go. So I think this made the entire code a little bit simpler, right? So we decoupled it from a lot of things and it became simpler. So now it is purely a logic, right? It's a purely logic of how we do collision. So Junior Freotus, I hope I pronounced your name correctly. Thank you so much for Twitch Prime. Thank you. Okay, so that's pretty cool. And essentially we want to do the same thing for vertical collision, right? So I'm just thinking, did I forget anything else? I think that's fine. So yeah, this has to be something like this. Yeah, so this is just like a rectangle. I could have just saved that rectangle somewhere. Now your sub, yes, kawaii freaking this. The signature of the vert collision should be the same as the horizontal collision. So this is going to be vert, right? It's the same. Here we have y. This is y. This has to be a speed, dy and dt. So then this is dy and y. I mean, w. Windows height. So we also remove that. That is not needed anymore. Overlaps. This one is kind of similar to this, except now, since we modified y, we have to do this and y. We don't have to do that. Bar dx. Oh, yeah. So the collision system also enables you with redirecting whatever you hit with the bar, right? The bar can redirect things. And if we're going to be reusing this collision for the particles, that means it's going to affect the particles as well. You know how a projectile can be redirected by the bar? Imagine that you can do the same with particles. That is a very interesting idea. Right. That is actually pretty cool. It's gonna work intrinsically, right? So we won't have to do anything because we're reusing the same collision system. So that's what makes it cool. We'll see how it works. So Bell Durant 428, thank you so much. Okay, we'll see how it works. So maybe if we want this thing to actually have any effect, maybe we will have to extend its life so the particles can. Oh shit, that's so cool actually. Because you generate particles when the projectile hits the bar, that means there will be enough particle near the bar to actually make it visible. Holy shit, I want to finish this thing. Okay, I'm sorry. This is just like a hypothesis, but we'll see how it goes. Alright, so if it's not dead. And especially like that, it just like makes the code simpler. I like everything that makes the code simpler. I really like that. So this is y, and then return no. So in here we just have border, right? So this is the border, this is the bar, and this is the target plus it index. I mean, it's a mistake, but I mean, the compiler will tell me anyway. So we also have an interesting thing called bar collision. And a bar collision is specifically only for projectile, and it kind of prevents the projectile from penetrating the ball. And I wonder if we want to migrate this thing for particles as well. I'm not sure, actually. I'll have to think about that. Okay, so I already made enough changes, right? So I already made enough changes in here. Now I need to see if this entire thing compiles. So as you can see, this entire thing does not even compile yet. Okay, you cannot do it like that? Okay. Really? That's actually kind of strange. Okay, I'm actually kind of surprised that you can't do that. By the way, how do you specify the type for enumeration? I don't quite remember. Well, that's how we did it. I mean, am I being dumb? Yes, I am being dumb. I'm sorry. Okay, there we go. So luckily, compiler always tells me if I'm doing something wrong. Alright, so we have target. So it doesn't like type mismatch. Oh, I see. So now it cannot infer that thing, so I have to specifically say collision dot target. Right, is that the problem? No. Okay. So type mismatch. Type collision, type S64. Can I just say S64? Will it work? So it's very strongly typed. I wonder if I can do something like this. And then something like this. I can. Alright. So it's not particularly convenient, but I can do that. Alright. So now we're using the horizontal collision. So let me try to do this kind of thing. Horse collision. So here we have to provide the position. The position that we're going to provide is going to be the position of the projectile. So it's approach X, approach Y, right? So something like this. And here is the approach dx and approach dy. So these are the pointers. The width and height is the same. It is literally the same. So it's going to be approach size. And dt is the dt that we love and know. And here we've got the collision, which we can probably check with a switch case. So if we have a border, right, we're gonna just emit some particles, right? If we got bar, we're gonna emit other particles. If we got target, this one is rather strange. I'm learning English watching you, thank you very much. You're welcome. I'm not a really good English teacher, especially with my pronunciation. But I'm really glad it's useful. Just spam XX until it compiles all, yeah, exactly. Star gets an address like in C++, yeah, it's basically the idea. It kind of makes sense. Look, to indicate that a type is a pointer, you put a star. Right, you put a star. To indicate that a variable is a pointer, that a value has to be a pointer, you also put a star. You use the same symbol to indicate that type is a pointer and to take a pointer to a value. It makes sense. It's in C++, the decisions of the operators don't make sense. In Java it makes sense. Right, and that's why it's easy to remember in Java. Right, the dereferencing actually kind of weird, but maybe there is a reason behind it as well. Okay, so here we're gonna do something like this. If case, I wonder, can I use like it? Is there any magical variable for the switch cases? I wonder. Is there any magical variable for the switch cases to refer to the value in here? Does anyone know? That would be kind of cool. Like, if I put it in here, it refers to the value in here. Java developers, does anyone know? That would be actually kind of cool, because I want to just check something here. Maybe I'm doing something wrong, right? Again, but I'm learning the language. Because one of the things I want to do, I want to just check if it is greater or equal to something like target. Right. I don't think so, but it would be super cool. Try it. Oh yeah, we can try that. Right. So because this is what I want to do. Right, because there's also a case for no, which also means, well, I still need it. Right. It would be cool, but would cause a lot of shadowing with for loops, I imagine. Maybe. I don't know. Okay, so let me actually just try to compile that. Maybe the compiler will tell me something useful. Target. Okay, it's a similar thing, so it's a collision, and then we spam XX. I feel like I'm doing something wrong with enumeration, so that's the problem. So it is not defined. Okay, so that essentially means that I have to save it somewhere. So horse, maybe HC. So an HC is the border bar, and then HC is greater than that. Right, so, and what do we have in here? What else do we have in here? Okay, I think it worked. Alright, so that's what I wanted to have. So for the border, horse collision, particle emit. Let's emit some particles. Right. For the border, we're gonna do that. So this is the position. Right, then we use the color, and then the particle emitter. Alright, do we need anything else? I don't think so, actually. So for the bar, the only difference here is just the bar color. For the target though, it's going to be target hit, and we just take the target pool, targets pool, and we take HC minus target, and let's see if it's going to work. I have a strange feeling that it may not work. Semicolon expected, sure. So let's put semicolons in here. Okay. Alright. And it didn't work. Collision. Target. Oh, maybe because of that it didn't work properly. Mismatched type, level, and direction. It's a pointer. Let's take a pointer. Okay, I'm surprised this shit worked. Alright. That's actually pretty cool. That is actually very, very much cool. You know what? The thing here is that this code is also applicable to here, which means that I can have a function that accepts a collision, right? So just a collision, and just does all of that for you, right? So we can, specifically we can call it handle approach collision, right? So it's going to be just that, and yeah. Which also means I can just take this stuff and say handle approach collision this, and then handle approach collision this, where I call this thing with the same arguments. There you go. It's the same code, it's handled the same. Alright. And what's interesting is that this is literally the thing that I basically factored out from the horizontal collision and vertical collision, right? So this is basically the code that got removed from these things. It's actually pretty cool. Okay, so everything more or less decoupled now. Okay, so this has to be called C. And does it work? Okay, it's pretty cool. Of course! Of course it didn't work first try. I mean, what did they expect? Okay. I wonder why. So nothing got updated at all, even though, yeah. Should a bar X be bar Y? Probably. Shit. Fuck them. Wait a second. Handle approach. Where is bar X? No, not really. It has to be bar X. It's specifically bar X. Yeah, so everything fine. Oh, it was moved. Thank you so much. Yes, now I know what the hell is going on. Yeah. Because dx and dy approach, dx and dy were actually 0 and 1. 0 and 1 because they indicated a direction. But then I changed them into absolute value of the velocity and I forgot about that. Thank you. Right, so now essentially, so they are initialized with just 0, 0, horse collision. So here I just multiplied by -1, which is fine, which is precisely what I want, so nothing special is needed in here. Approach dx. Okay, I initialize them with that. I'm gonna initialize them with 0, at least for now. And now, yeah. So what I need to do in here is actually approach speed. Approach speed. Yeah. I forgot that I actually changed the measure units for the speed of this thing. All right. Was it actually speed? I feel like it was. Which begs the question. Did I type the size? Oh yeah. All right. Okay. So I'm already getting tired, so as you can see I'm making a lot of mistakes. Yeah, that's cool. Alright, so and for y, we have to do approach speed y to redirect it vertically. Maybe it has to be negative. I think it has to be negative. Yeah, finally. Finally it works. Okay. I refactored the whole collision system and I didn't break things. So now I think there is still a little bit of a bug. So horizontal, vertical collision. So this bar dx, I think bar dx is still in those measure units or something like that. Right, so I initially... What do I set it to? Yeah, so I set it to 1, so that means this entire thing has to be multiplied by the approach speed. Actually, no. It has to be... okay. You need to take approach dx and multiply it by absolute value of approach x. Okay, so I think that's what needs to be happening when we are redirecting things. Alright. Okay, so that works. Okay, so that's cool. Now, the moment of truth. The moment of truth. We need to apply the collision system. 224. Yep. Thank you so much. Okay, now, the moment of truth. We need to apply that to the particles. Update Update. All right, so here we update the particles themselves. You see? So let's take the horse collision. So here we do it x. It y. It dicks. I'm sorry. Okay. Yeah, I'm 13. I'm sorry. So, and the size of this entire thing is going to be. So, what's the size of the particle? Do we have the size of the particle? We only have the. So in a render, when we render the thing, the size is actually this, right? So the size is actually this. Oh shit. So maybe I'm gonna not use the center. Yeah, I'm not gonna use the center. Yeah, because it will complicate the thing a little bit. So here's the actual size. This one is gonna be this. So this is the size, then dt, and we don't have to do that, but we also have to do the vertical collision as well. All right, that should be it, believe it or not. Rigolos, thank you so much for Prime. Thank you. All right, so that's pretty cool. So I'm gonna just try to build the thing and see if it works or not. Okay, so I forgot to essentially do something like this. Okay, we're using collision detection for the particles as well, and this entire thing compiles, which is cool, right? The moment of truth. I'm about to run the game and see how it works. Well, holy shit. Okay, so interesting thing. I think I know why this happens. The reason why this happens is because we do not ignore the dead particles, right? So what we need to do is just check the lifetime. We're only gonna care about the particles that have a lifetime greater than 0, because essentially we have thousands of particles, right? And on each frame we iterate 1,000 times, and for each particle we also check all of the targets. And there is, I don't know, like you've seen how many targets we have, right? So if I take a look at the parameters, right, target rows, we have 100 particles, right? So essentially we do 10,000 of iterations each frame. Right, 10,000 of iterations each frame, which is not particularly great. So I want this kind of stuff to actually, you know, be fast if we don't have that many particles. Is this on GitHub? I haven't finished writing the code yet. People, just a second. I'm gonna finish it and I publish it on GitHub. Oh shit. Can you see that? Can you see how they interact? Can you see how they... I'm not sure if it's even visible, but I think it's kind of visible. I think it is. Holy fuck, this is so cool. Yeah, you can see how they interact. Holy fuck. Though I'm not sure if thousands of particles is a good idea. What about this amount of particles? Right, so it will make it generally faster. I think it will make it generally faster, because I don't think we generate that many particles simultaneously. Yeah, that's very cool. Yeah, I did it. And now we even have more generalized collision detection mechanism, which is extremely cool. All right. So let's do a committee. The ball bounced off the particle. Did it? I didn't see that. Really? It shouldn't. Like, in no way it should actually do that. Maybe it's some kind of a different bug. Because we don't really check for particles. It definitely bounced me there. Well, maybe it's a bug with colliding with bar. So, but that's a completely different thing. Emitter period. Emitter lifetime. So what if I actually make it a bit faster? I wonder. That's a good idea. Okay. So now we're generating more particles. Is that a good idea? Probably. Another thing I have in mind is maybe speed up the entire thing. Oh, I suppose you can play with different parameters for the particles, but it's actually kind of fun. I don't know where you guys see that, honestly. Oh, okay. So, but it's not from the particle. Okay, I see. Yeah. Yeah. It's from the bar. It's a bug from the bar. Yeah. So it's a bar collision thingy. Yeah. There we go. That's a very interesting mechanic, if you know what I mean. Yeah. I really like this mechanic actually. So let me see. It just follows the bar. That's what's happening. So that means bar x handle approach collision. So this is basically what's happening in here, right? And this is what we do in here. Yeah. So this thing should only happen on, I think, vertical collision, right? But for now, I mean, I can just disable that. Oh my god, Emacs, what the hell? And say, are you serious? Ah, okay, I see. Yeah. Yeah, so I can fix that a little bit later. So I don't know what exactly causes that, but there's something wrong with detecting bar collision in some of those things. Right, so horse collision. So we do that, so this bar X, and then we do that and we report that we hit that. For the vertical collision, you know what? Yeah, it has to be bar X, it has to be. Because we constructing a rectangle based on its X. So I'll see what I can do in here at some point. Yeah. Okay, so let me go there, handle fix bar redirection mechanics, right? All right, I suppose that's basically everything that I wanted to do today, right? So I wanted to implement a particle system, and we actually implemented a pretty awesome particle system that interacts with the environment. I really like that. I think that's actually pretty cool. And the cool thing is that it uses the same mechanism, right? So that's what makes it cool. It uses the same mechanism, so it interacts with the environment the same way as the ball. Oh, and by the way, since we don't detect the bar stuff, it kind of gets weird. But I'm gonna fix that a little bit later, right? So, it's kind of interesting. Maybe it's not a bad idea. You know what I mean? What if we actually only play the particles on targets? Why not? How about that? So we only play on targets, right? Everything else, it doesn't matter. It's not a bad idea. I think I'm gonna leave it as it is, because when it plays particles on everything, it kind of gets too noisy, if you know what I mean. Did you read or watch something on particle collision? No, I never watched anything. The only thing I know about particles is that particle systems have things called particle emitter. So that's the only thing I know about particle systems. Right. Because I heard game developers throw around terms like particle and particle emitter. So that's everything I know. And I thought that maybe I'm gonna call one of my things that I have in the game also particle emitter, because it makes sense to call it like that. Apart from that, I don't really know anything about particle emitters. Again, I'm not a game developer, I'm just a software developer. I approach developing a game the same way as I approach developing any software, right? So I basically try to formalize the problem, and then once I formalize the problem, I try to solve it knowing the methods, using the methods that I know. So that's everything, and that's how I came up with this system. Is that a wrong approach? I don't know. So it works. It kind of does the thing I wanted to do. Collision, don't really know much about collision. So the collision system that I have in here, I invented myself by trial and error. It's actually a very simple collision system. It's extremely simple, and that's why it's so robust, by the way. So I can even demonstrate you how robust it is, because one of the problems that you encounter when you try to implement a breakout or ping pong or stuff like that is that your bar may start penetrating the ball, and it's kind of difficult to get rid of that. So my collision system does not do that. So maybe particle can penetrate the ball, but maybe particles can penetrate the bar, but the ball won't be able to do that. So if I take the bar thickness, I'm gonna set the bar thickness to 100, right? So as you can see, here is the bar thickness. And I'm gonna show you. So it won't ever intersect with it, so you can't do that. So one of the ways I solve that is that when the bar is about to penetrate the ball, the bar is stopped. So as you can see, it's sort of like stuttering it. So that's how I achieve that. So this is a very thick bar. So you can't see everything, but maybe I can do some things. So for example, I can just take the camera and put it somewhere here so you can see everything, because I want to show something interesting. Just a second. So for instance, I can actually put it really near to the border and it will still not penetrate. So I'm kind of trying to reach that point where it will be very close. It's kind of difficult. Is this ABB collision detection? Yeah, it's a very simple one. Maybe you should make the size of the screen a little bit smaller, because it's kind of... Okay. Yeah, as you can see, it still didn't penetrate. So I actually like press it against the wall and it still couldn't penetrate it. So there we go. Pretty cool. So, all right. Let me see. Let me actually bring it back to 20. No penetration. Yes. Bam. Bam. Alright. Bam. And now, yeah, let's do a committee and maybe even a pushy. Implement collision detection for particles. Right, I'm gonna push that right into the report. So in a worst case scenario, right, we're gonna have 128 by 128, no, really, 128 particles and then 100 targets, right? So 128 particles and 100 targets. So in a worst case scenario, we're gonna have 10,000 iterations per frame, but that will only happen if we saturate all of the particles simultaneously, and that is not gonna even last for too long. Right, so essentially we can get away with linear algorithms as long as we actually keep the capacity of these things small. So it may become a problem when we start increasing the amount of targets, right? It may become a problem. But in that case, I think I would start to actually use some special spatial trees for checking the collision with the targets. You know what I mean? So if we're gonna have a lot of these targets, right, I better build like some sort of a KD tree, right, and check it for that. And that way I could probably reduce it to log, right, so it's gonna be log, and that is gonna be 1,000, right. Something like that. That's basically the idea. And since the targets are static, right, they're static, I can just build like quite easily like a static KD tree and it's gonna work. Since so many ask about beta, can I link to a section of today's stream by John explaining? Yeah, of course you can. You're a sub, so that means you can just do that. So any sub can post any links in the chat. So should I play it? Should we listen to John? I think we should. And the problem is that Twitch is really slow for me. So let me pause the music and we're gonna open and listen to the message from Jonathan Blow himself. Everyone can download some RAM nowadays. It's alright. Well, I can't download any RAM. It's under sanctions. Anyway. So, this is Twitch in 2022. By the way.
Okay. Yeah, I mean, basically in the closed beta right now, I just decide who gets in and how do I do that? It's pretty simple. I just say, is this likely to be a person who's a relatively advanced programmer?
Maybe we should just let it buffer a little bit, I'm sorry.
Like they're not going to be writing hello world. And are they probably actually going to use it? And probably actually going to, you know, put it through its paces and help actually test it and engage in the community and, you know, help people think about how to make things in this language, right? Basically, I don't want to add a bunch of people who like want to be on the beta for prestige and like don't really use it. And I don't want to add a bunch of people who like don't really know how to program.
Fuck, I don't fit to that description. Fuck, how did I get into beta?
That's the decision-making process.
Shit. Okay, I probably have to implement something like more complicated than this game. I mean, is it more complicated than Hello World? I don't know. The problem is that John is such an experienced game developer that this kind of thing for him is probably hello world. So I don't know. I'll try to develop something more complicated maybe at some point. I'll try. Well, I reported some bug, like usability bug about the error message and stuff like that, and I also stream. Right, so I also help to popularize the language and also explain how it works for people who can eventually get to the beta. Maybe I am contributing to the community by my streams. I don't know. You guys tell me. But I don't know. I feel like a fraud right now. So the invaders was his hello world real and true. Yeah, so it is hello world. God damn it! I need to develop something more complicated than all right, so I guess that's it for today. Thanks everyone who's watching right now. I really appreciate it. Have a good one, and I see you next time. Love you all.